Okay, it's 8 o'clock. We have to get started. Okay, we still have two missions. One, I think, Stephen, he's competing in Texas for robot, and another one, James, is coming soon. I already see him coming. Okay, anyway, let's get started. Before we get started, first, I would like to introduce myself. Some of you may not know me so far, and I would like to introduce myself a little bit. So I'm going to use these slides from another course, let's say robotic course from this Lewis University. This is a university that I have been teaching for more than 10 years now on robotics and programming languages. So I'm using the slides over here to introduce myself. So my name is Eric Chow, Chou, okay, and I'm actually a senior member, Computer Science Teacher Association member, and USA Taekwondo coach. And then I graduated from National Taiwan University, the Computer Science and Engineering Department. And this is, some people may know, this was #1 in Taiwan, okay? So, and then after that, I go for 2 years of the military service in Taiwan's Navy as an officer, weaponry officer, okay? And after that, I came to US to study at USC for my master degree and PhD degree in electrical engineering and computer science. And then I'm currently a member in IEEE and serving in the Lewis University. So here's a show resume, my education, my publication, and my patents, US patents, Chinese patents. So my PhD thesis is on VLSI array sensory information processor. This is what this is like. This is an AI chip. It's like GPU. So back 30 years ago, I'm working on what NVIDIA is doing right now. So I'm working on those kind of the VLSI array sensor processing. So VLSI design, artificial intelligence, neural network, machine learning, array processor, communication. Okay, those are my fields. And I have used patent on CMOS image sensor, Ethernet, multilingual input for cell phone, and analog circuit, whatever, several US patents. So anyway, myself, I think about myself, I look at myself as a researcher because I want to like to do research. And I also teach in university. I'm also an inventor, so I work on several US patents, and I'm also an engineer. I would like to build things. Okay, anyway, so these are some products I've been working on before. I work on the Ethernet 5-port switch. So some of these devices are using my chip. And early days HP cameras sensor, the CMOS sensor, I have 4 patents on here. And then also the cell phone inputs for multilingual Chinese, Japanese language. And this is from my dissertation. So back in 1993, I started doing research similar to GPU structure called cellular neural network. And this is the neural network paradigm. So these two pictures are taken from my PhD dissertation. And I also work on the sensors, so silicon devices for sensor. So this is CMOS substrate and then pixel, image pixel. Can take pictures. Okay, anyway, these are my show experience. Okay. And then next one I would like to talk is, let me see. Okay, let's go back to our course. So basically, you are taking this one called AP Computer Science A, okay, AP Computer Science A course. And then we are going to follow this course revised framework. Okay, number one thing I need your cooperation is that please turn on your camera, okay? So I know that who you are and actually what you are doing, okay? Some parents complain that their kid actually missing, not listening. So I want to make sure you are not sleeping, okay? Is that okay? Any question? Any questions so far? Okay, so that's very important. I almost forget. Number one, we are going to follow this AP campsite A. Okay, AP campsite A. So let me explain what's the AP campsite A. AP campsite A is a computer science program in AP curriculum, and it's A means the most easy one, right? It actually is a programming course number one. It's a programming course number one, but in the old days, there is another course. So there is a AP Comp Sci A. There is another course called AP Computer Science AB. Okay, that AB course, this one with data structure. Okay, so this one comes with data structure. The AP course comes with data structure. This one, A course without data structure. So if you go to like Google it, okay, let's Google it. Let's Google AP Computer Science AB. Okay, let's actually look at the Wikipedia's definition. So there's a AP campsite A, and then okay, here you see College Board need to bring back AP campsite AB. Okay, so anyway, there's a course so-called AP Computer Science A, and then there's an AB course. So AB course come with data structure, but A doesn't. Okay, but in the year 2009, the AB course was canceled because that year only 19 students take that exam. For the whole United States, only 19 students take that exam. So they determined to give up this AB course. So then we only have the AP Computer Science A. Okay. So if you look at the AP Physics, AP Physics, AP Physics, AP Physics has AP Physics A, that's conceptual. Conceptual means you don't need to do a lot of mathematical calculation. And then there's a AP Physics B, and then there's a AP Physics C, okay. And then AP Physics A never offered, no AP exam so far. Nobody offered the conceptual physics. AP Physics B is algebra based. So you do algebra, the pre-calculus based, vector based, then you good enough for AP Physics. AP Physics C is calculus based. So you do hear that there's a AP Physics C mechanics, and AP Physics C electrical and E&M, electricity and magnetism. Okay, so that's a C. And then it's AP Physics B breakdown into AP Physics 1, 2 in 2016. This B course breakdown to 1, 2. So right now, some high school only teach 1, some teach 1, 2. So very bizarre. Same thing for AP Computer Science AB right now. So some high school, when they stop AP Computer Science AB, but their high school still teaching AP Computer Science A and plus B. So typical high school like Lynbrook, okay, Lynbrook in Cupertino would teach B as well. Okay, Saratoga maybe. Some of the high school, I do know they also teach the B part. Okay, so AP Computer Science A is supposed to be the first programming course. Programming course. Okay, first programming course. So teach you the programming language. And in the year 1993, that's the first year that we have AP Computer Science A. At that time, C double plus is used. 2003, it changed to Java until right now. Okay, some people is talking about maybe this AP Comp Sci A need to change to Python, but at this moment we're still using Java. And Java's advantage is it teaches you the object-oriented programming. So that's why Java have been used so far. So you are entering into this course for AP Computer Science. A is focused on programming. Okay, it's focused on programming. You may also know that there's another course called AP Computer Science Principal course. So this principal course teach you data, internet, computer hardware, and the programming, several things. So it's an overall introduction to computer science. This is supposed to be the first course in CS, but it's actually very broad. The programming may be only 50%. And then another 50% is concepts. So the one we are talking about right now, the APCSA, is a programming course. This one is 90% on programming, maybe only 10% of the concepts. So these two courses are totally different. You take CSA first, then CSP, that's fine. You take CSP first, and then take CSA, that's fine. In Taiwan, in National Taiwan University, the freshman year, the first semester, we teach CSP for one semester, and then CSA for second semester. Okay, that's actually typical in Taiwan. Okay, that's typical in Taiwan. But at this moment, this actually back 30 years ago. Right now, this CSP and CSA already pushed down to high school. Okay. Okay. Anyway, these are the differences for these two courses. So if you think that you are not belonging to CSA, let me know. Okay, maybe you should go to the CSP. We don't know, but if you are going for serious programming, this is CS course is the right course for you. Okay, so we are assuming everyone coming here is for serious programming. Okay, any questions so far? No. Okay, so this is about the AP exam and AP course. Now, some student, maybe Harrison and maybe Jen, you are only 8th grade. Okay, now I'm talking about 8th graders. 8th grade going to be 8th grader or going to be 9th grader. Are you okay to take AP CSA while you are in middle school? Yes. Okay. The College Board allows students to take AP early. Okay, so if you want to take the exam, let me know. Okay, I will actually help you to find school that give you the credit, so you can send your transcript to college, and you can also take the exam next year. Okay. Are you suggested to take it? Yes. You take it early, you will have many advantage over other students. Okay, because you can take more AP later for other subject. There are tons of subjects that you can take. You never run out of AP that you can take. Okay, but you take the AP early, you will actually learn the programming skill early, and then you will be have some advantage. Okay, here is the physics 1, 2, and C that I mentioned. So these two in the past was AP physics B combined, okay, in one course. Now split into two course. Okay, and that actually is AP exam. So the exam date usually is the early May. Okay, so May 2026 there's an exam. And then I suggest everyone here to take the exam. Okay, it's good for you, and you will know how good you are. Okay, schedule right now we are June. So from June to November, we are going to cover AP CSA's material. And then starting from November to maybe March or maybe February, we are going to teach you the AP computer science, the AB part, the B part, the Java 2. And this one will lead to user code. So in a way, this AP ComSci A is only a semester course right now. Okay, the new standard is only a semester course. I'll talk about it later. But it was a 1 year program before, but now it's only one semester course. And then if you want to go for user code training in Java, you will need that AB part. So and then starting from February, we'll teach you the review to take the exam. That's a 3 months, 10-week program to teach you review. So some students take my CSP before, you know how we review the material. So basically, this is how this course is structured. Okay. At this moment, we are right here. We are on the AP ComSci A. Okay. And then we will add extra material. These are not covered by AP CSA exam anymore, but they are essential, actually essential. So if you finish AP CSA, what can you do? Let's actually look at how you connect to the university. So first one, if you are going to Berkeley, so there is a course called 61B. So Berkeley's this course is the second semester course in Berkeley. It's Java based. Okay, we talk about it because it's Java based, but this one directly jump to Java 3. So that means that you need to prepare for AP CSA plus APCSB part in order to go to this CS61A. If you go to Stanford, Stanford has CS106A, then this one is equivalent to this APCSA. It's pretty easy. So most of our students would bypass this CS106 and then go to CS106B course. That's OOP course. Any questions so far? Any questions so far?
No.
Okay, so I'm talking about how this AP course connecting to college. Okay, I picked the Berkeley and the Stanford as an example. So that this means that these courses are very essential. Okay, prepare you for the college education. So as you can see right here, if you do this curriculum for APCS for the Berkeley CS61B, I would say your AP Computer Science A probably only 3 weeks. That's it. They just review for 3 weeks. That's it. Anything not teach in APCSA anymore. And then this is the first Java course in Berkeley. So if you don't know it, you'll be in big trouble when you go to Berkeley. Okay, these are so many weeks still ahead. Okay. Okay. Anyway, that actually is how you connect to different courses. So the course standard right now, what we are using is this one. It's called College Board Revised Course Framework for AP ComSci A. The version that I received is using the course standard of the new school year. Okay, so different units and different things. I already designed the new slices. So this year's slices are newly designed. And then they will be following the standard. Okay, at least from now to November, we are following the APCSA. Okay, will prepare you for the AP exam. And then beyond that is the CSB part, and it's working for user code and more advanced programming. Okay. Now, I'm not going to go into this detailed description. Okay. If you need it, I can send it to you. Anyway, let's go back to our course. And then next one, what I want to cover is our website. Okay, our website is right here. This is the website I'm using. So what I will do is let me start over again. So you go get a browser and then you say http eco24.com. Okay. That's my website. Originally, I want to register ecacademy.com, but already being occupied by other people. So then I pick another name called eco24.com. That means that 24-hour coding, okay? That means 24-hour coding. So eco24.com, that's my website, okay? So this give you some brief introduction for my course. Anyway, here there's an EC Lab. Okay, this EC Lab actually, you click it, it will lead you to the website for our course. Right here, actually, let me log you out, okay? Log me out and log in again. So let me log out. So let me close it one more time. So that's actually click the EC Lab again. So you will go to here, you will get a login page like this. Okay. Different courses anyway. And then you actually click this login on the right upper corner. So you click it, you'll see this working page, right? EC Academy, whatever. You put in the password and your username. Okay, your username is your first name plus your last name, all in lowercase. Okay, your starting password is always ABC123 $. Okay, everyone the same. Okay, everyone the same. And then you need to change your password when after you get in. So anyway, I'm going to log in. And you should be able to see whatever course you have. But at this moment, you are supposed to see this course, this Paracan course. Okay, this is a Paracan course. So this Paracan course give you the AP Computer Science A SU 2025. There's a 22A. This A means that new version for 2026. We call it 22A. Okay. In the past, I called it 22. Okay, these are the older standard. So the new standard, I use the 22A. Okay, anyway, you click it, you go to this course, and you will see the textbook is right here. We use this Java Early Object textbook. So then you actually click it, and then here you do see a HTML link, chapter 00.html. You click it, you lead you to the textbook. So you don't need to buy the textbook. Here, we will give you the electronic version. Okay, so you do have the introduction. And then you do have the textbook material here, okay? Anyway, we are not going to go into the detail. Just let you know that the whole thing's there. So as you can see, this one, Java 1 is Unit 1 fundamental. Java 2 is object-oriented design, okay? Java 3 data structure, DSA course. And then Java 4 for networking and parallel processing, okay? So what AP ComSci A covers right now, only this portion and up to this portion. That's it. The new 2026 standard only cover up to here. 3 years ago, 3 years ago, the older AP capsite A, including this part, and then the whole thing right here. So right now it dropped down to a single semester course. Originally it was 2 semester course. So we will teach this part in the November to March timeframe. Is that okay? Hello, is that okay so far?
Yeah.
Yeah.
That's what is missing, okay? Missing for object-oriented programming. You need it if you want to go to user code competition or connect it to college, okay? The 1 semester format won't work. At least it doesn't help you to go to some top university like Berkeley, okay? It's definitely not enough. Okay, anyway, these are the material, and then I do have the PDF. I do have the PDF for the textbook. Anyway, I don't have time to find it. I do have a textbook in PDF. If you need it, let me know. Okay, so that's actually the material that we will cover in this course. Now let's get started for the chapter 1, okay? Okay, one more thing. All of the homework, I'm sorry, let me go back to the website. I haven't finished yet. I'm sorry. So let's go back. So this one, all of the in here, you do have this textbook for early object. There is another textbook called Sing Java 2.0. I used this one for pre-AP before, but this year I stopped the pre-AP computer science course. I stopped it, okay? So I merged it together with this CSA course, but the textbook's still here, okay? I'll let you refer it. And then each chapter, okay, let's go to chapter 1. So each chapter, we do have this PDF. So you don't need to take too much note. You need to have a notebook, but you don't need to take too much note. You basically can study, you can actually download these slices that I'm using. So right here, this button will give you you can download it from here. Okay, this one is the download button. You can download the file, let's see, download it. Okay, and then you open it by the PDF reader, okay? Then you should get this PDF to study, okay? So that's about the PDF. So we give you the slices, and then there's a sample code. Sample code you can download and unzip it. You will see the code that used in the chapters as examples, okay? And then we have the quiz. Now you need to work on the quiz, exercise, and project. Every chapter, almost every chapter, all has these 3, okay? So let's see, if this week we finish chapter 1, the next week, chapter 1 will be due. So basically, I would actually monitor your progress in the homework. So I would send these updates of your homework every week. Okay, so I will say who we work on it, who haven't worked on it. Okay, so meeting day is today, but next week, chapter 1 will be due on 14th. So I won't send you any more notice for which one will be due. I'll just, after the chapter is done, it's due next week. After chapter is done, it's due next week. So you need to work on it, okay? You self-monitor yourself. Okay, so this is 3. And then there are some extra reading material as well, right here. Okay, so this course is well structured. So we actually divide it into different chapters. And then every week you follow the homework. Every homework you need to work on it, okay? Every homework, so it's all on the network. Okay, and let me know when you have question. If you have a question, you actually can post right here. So let's assume that, let's see, for example, like Kingston. Okay, so Kingston, you have a team. So I have you and your mom in the team. So you just post your question right here, and usually within the day, okay, I would say within 24 hours, I'll get back to you as soon as possible. Okay, is that okay? So every student has his own group. This is Stephen's group. Okay, and then here, whatever Lina's group. Okay, different Leo's group. Every student, I do form a conversation group for the parents and students. Okay, so your homework, everything will be sent to Facebook. If you don't receive it, let me know. Okay, if you don't receive the graded homework or something, let me know. Okay, that's actually from the textbook. For the communication, we basically we use email and Facebook Messenger to communicate. Okay, and every chapter you have to come to here to submit your homework. So let's see. If you want to submit the homework, you actually let me actually change my role to student. So let me change it to student. Okay, so now I'm behaving I'm a student. So I can work on the chapter one. Okay, chapter one. So right here, you will add admission, okay, and then you actually would add your file. Let's assume that you actually choose a file. So when you submit your homework, okay, let's assume here, okay, let's assume this is the, let's see, let's assume that here you have, this is my homework directory. Okay, let's assume that. So let's assume that this is the homework directory I want to submit. So I can use to zip it, add to archive. Okay. And then I add this chapter to there, and then I upload this file. So the file will be in. Then you save change. Okay. And then now there's an edit submission. Edit submission means that you are not done yet. So you continue to work on it. If you are sure that you're already done with the homework, you're going to submit, then you still need to click the submit button and then continue. Then the homework have been submitted. Okay, this is the process of submitting the homework. So if you are more than one file, I suggest you to put them into one zip file. Okay, if you have more file than just one file, I suggest you to put them into the zip file. Okay, any questions so far?
No.
No? Okay, I'm returning to my normal role. Okay, that's about homework submission. Now, okay. So that was, I think, good enough. And textbook we covered, okay? And then schedule, we talked about it already. Now let's go back to our chapter one. So chapter one will be introduction, give you the basic understanding of what is Java language and computer science, okay? Okay, so let's get started. So this chapter, okay, here it always has the AP curriculum goal. These are coming from College Board statements. So that's what need to be covered in this chapter, okay? And then objective is what we have in our content. Okay, so the AP curriculum goal is set up by the College Board. And then this objective is our goal, our material. Okay, so sometimes there are some topic I would say is non-AP topic. So it's more advanced, may not be covered by AP curriculum. Okay, but I will sometimes would cover it as well. Okay, so first thing is, what is computer? Okay, so computer, you can search for Wikipedia and then you can find some definition. But okay, let's go back. So Kingston, what is computer?
It's like a device that can like process things
Can process what kind of things?
like computations or like programs or
Ah,
anything.
so what is computer science?
Uh, it's like how you like give instructions to computers.
No. Okay, Jane, what is computer science?
The science inside the computers, like CPU, GPU, maybe.
No, that's not computer science. Belinda, what is computer science?
It it processes information and like
Information?
um
Hmm. Try. We are just discussing, okay?
it can perform math, I guess.
So you are still covering about the computation part, okay? Let's see. Harrison, what is computer science?
Like the way you like program a computer, like
That's
within like
programming. That's not computer science. How about Leo? Leo, what is computer science?
Coding, operation of your computer.
That's still programming. That's still not computer science, right? Okay. Anyway, it's okay. We are discussing. Okay, we are discussing. So far, I would say everyone think about programming, a bit about coding. Your understanding for computer science is primarily coding. Okay, but that's not exactly right. Okay, that's not exactly right. Okay, let's talk about first. Before we talk about computer science, let's talk about what is science. Science is the systematical way of study. So you set up the scientific method, you design the experiment, right? You actually come up with a hypothesis first, and then you come up with experiment, and then you do experiment to gather data, and then to verify if the hypothesis is correct or not, right? That's called science. So science is a process. It is a systematic way of studying things. We call it science, right? This is actually the definition of science. Then science has different branches. You have biology, you have chemistry, you have physics, you have earth science, several environmental, whatever. There are several one of them. One of the branches is now called computer science. So computer science is the science about computing. Science about computing is called computer science, right? So you studying the nature of the computing. What is the computer's nature of the computing? A plus D takes square root. How to calculate it? That is a computing. That's a computing, and how we find a good way to calculate this take square root of A plus B, and then putting them onto electronic devices to calculate it. This is computer science. Okay. You actually have abacus to calculate arithmetic computing. That's ancient computer science using abacus, right? You can use a multiplication table to do calculating. That's also computer science. That's called table lookup method. That's one kind of computing. That's called computer science. And then in the 1950s, people start to using the electronics to do computing. So they come up with electronic devices called semiconductor and switches and transistors to do computing. And then that's the modern day computers come up, right? And then that actually trying to solve some equations trying to solve equations. And then, okay, so the first language is called Fortran. Right, Fortran. So Fortran's name is Formula Translation. Right, it's formula translation. So, and in the older days, formula translation, the calculation of scientific formula is very important. So Fortran is used to calculate all the computation to send the astronauts to moon, right? To have the rocket science. They all depend on Fortran, right? That's called Fortran. So at that time, computer science is like that. And there is a company called IBM. Who know what IBM stand for? Leo, do you know what is IBM? About Harrison, do you know what is IBM?
No.
IBM is International Business Machinery. So they are building computer to do business. That's the mission of the IBM. So IBM is very successful to come up with IBM PC, IBM mainframe computer, IBM database, IBM so many things. Their main purpose is their logo is called International Business Machinery. Okay, so in the early day, they are targeting at the business, they are targeting at the science, they are targeting at the rocket science, using computer to help them, right? So that's the computing that we talk about in starting 1950, 1960, okay? But nowadays, okay, so 1960, they are algorithm-based, so they are formula-based, I would say formula-based. And later they have the algorithm-based computing. So they have C language, Argo 68, something like that, right? So they are algorithm-based. But now the horizon of the computing rise. We have AI, machine learning coming in. So AI machine learning is beyond algorithm. You need to do computing using a new set of the rules. It's no longer just algorithm. So some people say that, oh, in the AI age or machine learning age, we don't need the algorithm. We don't need to learn computer science. That's wrong. That's definitely wrong. In the AI age, that just means the horizon of the computer science have risen. It become broader. It have more contents. AI and machine learning being included into computing. So in a way, human knowledge is expanding. Computer science is expanding. We are studying the science of computing. The science of the computing is to expand humans' computing power in terms of hardware and software, both. So you need to design higher speed NVIDIA GPU. You need to design CUDA, that's the software. You need to design automatic driver. You need to design security, cyber security for digital coins. That's always expanding the horizon and the boundary of computer science. So in a day, what I want to say is that in the old days, you use abacus. You only do 2025 plus 2024 plus 1 plus 2, something like that. Okay, you do arithmetic. That's abacus. When you do Fortran, you have a language. So you do a whole computation. You solve the problem of the Newton's method to find the square root to find the equation's root, right? And later you have the algorithm. So you use the algorithm to do computing. You solve the problem of the chess, how to play chess by algorithm. But that's not enough. That's computing. The algorithm-based computing cannot beat human brain. So at that time, if people play with computer chess or Go game is dumb. But later, people use artificial intelligence to beat the human mind. Nowadays, the best computer can beat the topmost Go game players already, right? There is a Korean player lose to AlphaGo, right? There's a Chinese guy as well. So that means computers keep expanding. And we study computer science is to expand, always to expand the boundary of the computing. And you find a new set of computing and then put them into a computer, make it work, or you build a bigger computer, or you build a faster computer to solve it. Then you are improving the computer science. So computer science, in a way, just like a biological science, just like a physics, just like chemistry, it is a science. It is a science about computing. It is not just doing algorithm. It's not just writing code. That's just the basic part. That's not the whole things about computing. Computing is to formulate the whole computing using your math, using your statistic, using your machine learning model, using your large language model, using your adaptive filter, using those models to build your model for your computing, and then put those computing onto computer. And then nowadays, computer maybe not big enough, not fast enough. Let's build the H200 NVIDIA chip. It's still not enough. Let's build the H300, GB300 to solve it. Okay. So human are trying to get faster and faster devices to do computing. And then TSMC is fabricating smaller and smaller, deep submicron, micron nanometer chips to make the AI go faster and faster. That's the nature of computer science. So computer science is not just coding. It's just not, in a way, it's not just computer science. UC Berkeley is called X. It's EE plus CS. And nowadays they have an MET program. So you add the business HAS program into it. So business is also in there. Okay, so basically the field for computing is expanding. Coding is only a small set of the computer science. It is part of computer science, yes, but it's not the whole thing about computer science. You need to learn math. You need to learn physics. You need to learn programming language. You need to learn hardware. You need to learn a lot of things to put, or even finance, to put your computing onto a proper computer to solve the problems. Okay? Is that okay? Okay, I give you this definition, so I want you to remember that why are you studying computer and computer science? Okay, so these are slides I just let it go through. So the first days, all days, generation 1 computer, I use this IBM as example. So there's a guy type in there, this is input unit. There's a CPU right there. This actually is a processor, I should call it processor. Back right here, there are a few tab drivers. These are memory. So some backup memory is right here. So the whole room is one computer. The whole room is one computer. This is back in the 1960s. IBM. I use IBM as example. International Business Machinery as a first generation computer. Second generation in the 90s, 80s, 90s, desktop computer comes up. Okay, so it's like this. And then this actually is not portable. So later it go into notebook, cell phone, iPad, iPod, all kind of portable devices. So this 2000, since 2003 to 2015, we call it mobile computing, right? So I use Apple as an example. These are the different period, okay? This different period of computer science. I picked the upmost company for it. Now, after 2015, this guy, Amazon AWS, we start to hear the word cloud. We started to hear the word machine learning, right? This is 2015 up to 2023. Amazon is the most popular company, leading in technology. But it's gone. Then next generation, I don't have it. Let me actually browse from the internet. So since 2016, 2023, nowadays, next generation will be bots. Okay, what is a bot? So you will start to see all kind of bots, chatbots, right? Robots, all kind of bots. Anything that can do automatic computing is called bots. So who is leading in this age? Definitely NVIDIA, right? NVIDIA, OpenAI is leading right here. So starting 2023, we start to see the stock price of NVIDIA going up higher and higher because now it's the age of the bots. So let me copy this image. That's what you want to study right now for computer science. It's no longer just algorithm. You are going to build bots when you go to college and actually graduate. All kind of bots. Let me add it in, okay? I'm sorry. Next stage is bots. Any questions so far?
No.
So this, I give you 4 or 5 stages of computers using different company as example. And then we do have the hardware. That's called circuit board. This is a motherboard. So you do have a CPU, DRAM, you do have PCI Express, I/O part, you do have Ethernet connector, you do have a hard disk driver, whatever. This is the board. I don't want to go into detail. You can study, okay? And then you do need to know computer systems diagram. You have the input device, output device, you have memory, you have main memory and backup memory, and you do have CPU, okay? So Henderson, what's the difference between main memory and backing a secondary memory? What is main memory? What is secondary memory?
Like memory stuff, like after like a while you put it into like secondary memory.
Yeah, what is a secondary memory?
Uh,
And what is main memory? What's the difference between the two?
I'm not sure.
How about Jen? Do you know?
I know what main memory is, I think, but I think the backing storage is like SSD or HDD maybe.
Yeah.
Main memory is
So this one usually means a hard drive. So when you turn down the electricity, it's still there. That's called secondary memory. Main memory, if you turn down the electricity, you'll be gone. Is that okay? Okay, so next one, there is a CPU. In CPU, there's a control unit. There's one called ARU. Okay, ARU is short for arithmetic and the logic unit. Okay, this is called CPU. So CPU is responsible for computing, but their data and the program coming from main memory. Memory actually uploaded from the secondary memory. Okay, so this is the logic view of the computer. And then these are the different input devices. Okay, input devices. These are the output devices. Okay. So in a system, you do have a system bus connecting CPU, memory, input, and output. Okay. So we do here, there's a 8-bit computer, 16-bit computer, 32-bit computer, but nowadays we are using the 64-bit computer. Okay. So Belinda, what does it mean by 64-bit computer? You do download is a AMD 64, so why AMD 64? What does this 64 really means?
Does that have to do with the IPv6?
Wait, which one? Can you say it again? I can't hear.
What is why the computer we call it 64-bit computer? How does this 64-bit define? It's defined.
Wait,
Yeah, you go ahead if you know it.
I think it's because the CPU runs in 64 bits. I don't know.
No. CPU is way wider than that. Maybe 200
Or maybe
more
like
bit.
how many like processes can it do with like
No.
one core?
That's how many core, how many threading. That's not number of bits. How about Kingston? Do you know? Hi, Kingston,
No.
hear me?
Yeah, I can hear you.
What is 64-bit computer? When people ask you, well, I got a new 64-bit computer. And then some people say, I only have a 32-bit computer. So what is the difference between 64-bit and 32-bit?
I don't know, like how
Okay.
many a computer can process like at a time.
That actually defined by data bus.
No.
This is system bus. When it is 64-bit, that means a byte. Each byte is 8-bit. So if you ship 8-bit from memory to CPU, that's 64-bit computer. If you every time you only ship 4 bytes, that is a 32-bit computer. Is that okay? Hello, is that okay?
Yeah.
So in a way, if your system bus is wider, then your program will go faster because your memory to CPU every time the number of bits is higher. You ship more data to CPU in a way. Okay. So let's see. So if you actually go to the Windows Pro computer, right? Let's go to Windows computer. So C drive, I'm using Windows. There's a program file, x86, right? 2 different program files. This program file x86, you will click in. These are programs for 32 bits. These are programs for 32 bits. If you go to the program file without the x86, these are programs for the 64-bit programs. So by the way that they install their program, we will know which program is 64-bit, which program is 32-bit. Is that okay? So in a way, there are some computer vendor nowadays is doing 128-bit or even bigger number of bit. Okay. So some companies say, let's actually look at NVIDIA again. NVIDIA has the GPU, but another thing that they are doing is the HBM4. Anybody know what is HBM4? Samsung, Cylix. It's a high bandwidth memory. High bandwidth memory means that from your memory to your CPU, the bandwidth is way higher than before, way higher than before. That's how this high bandwidth AI computing is. You have SoC, your CPU right there. You have different high bandwidth memory ready to ship a large amount of data to your CPU. So in a way, your hardware is not just CPU, GPU. You also need to have a good high bandwidth memory to support your AI computing. Okay, is that okay? Is that okay? So you study the system bus, you study the system diagram, so you will know about what is the best hardware arrangement for your computer. Okay. Next one, let's try next one. Next one is operation system. So operation system is a piece of the software that manages the whole resource on your computer. So usually Mac OS, Macintosh operation system, Windows is the Windows operation system, Linux is Linux operation system. So Linux can work on the x86 CPU. They can also work on the ARM core CPU. Okay, but operation system is on top of the hardware to manage the resource for you. Is that okay? Any questions so far? Okay, so that's talking about hardware, software, input, output, whatever. Okay, then we talk about computer science already. Okay, so I don't repeat the computer science. Next one, what is computer engineering then? We talk about computer science. So what is computer engineering? This one, Kirsten, what is computer science engineering?
Like designing the hardware.
Kind of. How about Harrison, what is computer engineering?
Like the engineering of like computers, like this designing and like manufacturing.
Kind of. Okay, anyway. Engineering is building product in that domain. So computer engineering is a building product for computer. So you have electrical engineering, that's a building product in electricity. You have chemical engineering, they are building products for chemical products. You have civil engineering, that means they're building the product for housing, for bridge, for civil use, for citizens use, right? Public construction. So any of the engineering discipline is to build the product. So computer engineering including the software and hardware engineering of computer. Okay. So here you have computer science, you have computer engineering, they are different. And there is another discipline called software engineering. So this one building the product in software. Okay, so these are the basic difference for these different major. And there is another one called data science. So data science is the science of studying data, big data. So you need to have a computer science, mathematics, and domain expertise. This usually is business. Okay, so you do statistic, data processing, and machine learning. Okay, these are if you go to the college. These are the topic, modern days topic people like to study. Okay, and these are different branches of the application for big data. Okay. Okay, we finish those big words, the computer science, those big words. We are going into the Java language and programming language. Okay. So Java 24, the version that nowadays you download is Java 24. But AP exam only tests up to Java 8. Only tests up to Java 8. So Java 8 maybe 2005, 2008 already had Java 8. Okay. Now it's Java 24. Is that okay? Java, the first version come out in 1995. Okay. But now it's 24, version 24. And we install the BlueJ for you. There are several different editors. We pick BlueJ because high school student has 49% using BlueJ. And it's a lightweighted editor, and it's IDE, integrated development environment, okay? Any one of these is okay. I don't actually object to it, but some of them are too big for high school students. Or if you use IntelliJ or Eclipse, they too much for high school students. BlueJ is easier, and you will learn the language better using easy tools. Okay, later you can change to other tools. So we do have this BlueJ. Everyone install it. If you haven't been installed with the BlueJ, let me know. Okay, after class I will help you. Okay, anyway, let's work on the first program. Okay. So first you need to install your BlueJ. Okay, I do have a BlueJ icon right here. Okay, so I'm going to let's use it. So I'm going to actually create new project. So right here, if you are using Macintosh, it's on the top bar. Okay, there's a project. You click project and you do new project. So let's choose. You can choose a directory. So usually I choose to a target directory. So let me choose this E drive, EC Academy, AP Computer Science 26 EM. Okay, and then right here, let me create a new directory. Let's call it BlueJ. Okay. Okay, so inside BlueJ, I pick this as a folder, and then I'm going to create a project called Chapter 1. So it's a folder. So when I create this Chapter 1, let's go back to the hardware. Let's go back to the hard disk. Right here, the BlueJ, under BlueJ, there is a Chapter 1 will be created. And right here, you have a package and README file. Okay. So now let's actually close the original one, close this one. Let's keep this Chapter 1. And then I'm going to new a class. So you click new class here. Let's call it hello world. Okay, so you do get this one. Project comes with colors, so you know about which level of the code it is. So right here, this is white and yellow. Usually we just delete it. So we started from here. So let's do public static void main. Every program start with this. Okay, public static void main. String left right bracket ARGS. So at this moment, don't ask me what these are. Later we'll tell you what these are, but you need to remember public static void main, parentheses, left string, left right bracket, ARGS. Just remember this, okay? You need to remember this. And then let's put in system.out.println line. Print line, you do hello or okay, you finish your program. You need to finish your program. Once you finish, you can click class here. You can save. Okay, you can save, or you can do compile. Okay, after you compile, you can run. You do right click main void main. You click it, and then they come out with a parameter. You just click OK. Hello world is generated. This is the first program we generated. Okay. Any questions so far?
Well, how do you run it again? I didn't catch it.
Run it, you come to here, you right click, choose this main, void main. And then click OK, you run it. Is that
Okay,
okay?
got it.
Okay, these are actually from this computer, from Bluetooth. Let's don't use the Bluetooth. Okay, let's don't use the Bluetooth. Let's assume that we actually go to this chapter 1 right here, right? Go to right here. That's actually at least right here. I can click the window R. Bring up the CMD, okay, command line. So let's actually let's see. Click OK. So that will bring up the command line. Then I will change directory. So change directory, I say E drive. I'm using the hard drive E drive. And then I need to change to this directory. So I do CD. CD means change directory. And then click and right click copy. I got the path. Put it right here. I'm going to switch to that directory. So dir check the directory content. Okay, right here. Now, I need to create a new program right there. Okay, so in order to create a new program, I use a Visual Studio Code. So I do code that bring up the new Visual Studio Code. Some of you may not install this one. Okay, that's okay. So right here, you do see those hello world already been there. I'm going to ignore it. So that's actually create a new file. This one, let's call it hello Java. That's Java. Okay. So I create a new file called hello Java. Okay. And then let's do this. Let's do public. So here you see, if I use the Visual Studio Code, they don't give you the skeleton. So you have to type everything. That's why for beginners, I prefer to use Bluetooth. So right here, you have to type everything. So this one is called hello Java. Then right break it. Okay, this is the topmost unit. You create a class definition. Then you put a function called public static void main string, then right break it, arts, then right break it. Okay. And then right here, you put in system.out.println line, and you put in welcome to Java. Okay, you're done. Okay, let's assume that this is done. Done, you do file and save. Okay. After you do file and save, let's actually do dir right here. You do see there is a hello Java.java. Okay. And there's a hello world. Hello world is the previous program. Anyway, right here, you do call Java compiler Java C. Okay. And then hello Java.java. So you're going to do Java C. You have to install the Java JDK. Okay. Some of you haven't installed it. Okay. We can find time to help you to install the Java JDK. But anyway, you do use Java C for hello Java, and you do go. Okay. After you finish this Java C, you will have a hello Java.class file being created. This one we call it bytecode. Okay, it's a temporary file called hello class, hello Java.class. But anyway, we are going to run it. So you do Java. Java is a Java virtual machine. Then hello Java. No .java, no anything, just go. And you will print out welcome to Java. So basically you do compile and run. Compile and run. Is that okay so far? Is that okay so far?
Yeah.
Anyway, let's actually quit our Visual Studio Code. Okay, let's execute down. Let's also quit this hello world. So let's assume that actually I come to a new directory. There's a BlueJ package right here. So I don't click this this package anymore. Let me click this package. You will bring up this directory one more time. And then you see the hello Java also in there. You double click it, you can see the code. Okay. So let's actually do this. Okay, let's actually come to here. Let me actually open this hello Java by another program. Let's actually use Notepad++. Okay, so right here, I do have this Notepad++. I will choose language Java. Okay, welcome to Java. Let me put in one more line. Let's put in system.out.green line. And let's put in my second line. And then I'm going to save it. Okay, I'm saving it. Wait, you see, BlueJ automatic in that line as well. So your BlueJ in a way is connecting with your outside editor. So don't worry that your program editing in BlueJ, your program editing in BlueJ can always be used by Visual Studio Code or by Notepad++. Is that okay? Does that make sense?
Yeah.
So in a way, I prefer this one. That's why I prefer this one. You compile and then you run. Okay, so you run. Okay. Okay, so that's how you run your first program. Okay. That's our first program. Let's continue. Okay. So we do demonstration, then you edit your file by BlueJ or Visual Studio Code. So you come up with a, say, hello world.java. Okay, hello java.java. So this is the Java file being created. So this is the Java file, we call it source code. Jen, what is source code?
Me?
Yeah, Jen.
Oh, source code is like the code that actually makes up the code the thing program in
So in
plain
high
text.
level language, you call it source code. So .java.py, Python file.py, or .cpp in C++, we call it source code. Okay. So you edit your source code. That's what your program is. So you create welcome to Java, and then you do Java C to compile to a bytecode. Bytecode is the class file. So bytecode is a intermediate code, and that's actually machine code already. And then this machine code can be sent to different machines. You can send to Mac OS, can be sent to Windows, can be sent to Linux. It's a class file. And then you do Java to run it. So compile and run, compile and run. It's a whole process of compilation. Okay, so this chart very important. Okay, let's show you how it's done. So basically, you compile different bytecode, and this bytecode can be run by Windows, by Sun microcomputer, by Macintosh, by Linux. Same bytecode can run on different virtual machine. This is called cross-platform, platform independent. You develop one code at one platform, but can be used in other platform. We call it platform independent. Java is platform independent, but C++ is not. C++ you compile in Windows. Those programs cannot be run on Macintosh. you have to compile again by different compiler. Okay. Any questions so far? So Java, you compile to that class, and can be run on different virtual machine. We call it platform independent. Okay, you can run the program regardless which platform it is. Okay. So Java language is object-oriented programming language. Okay. So we teach you Java. And then next year, after you finish the AP, we will teach you C#+. If you stay in our course, we'll teach one more year in C#+. And then right now, 1 year in Java. And some of you already finished Python, HTML, JavaScript. That's 1 year. So by doing this, we'll teach you 4 languages in high school. Okay, but right now you are on the Java course. So Java is structured programming. It's also object-oriented programming. It's also event-driven programming. Okay, structured programming means that you use a for loop, if then else, those kind of language, or you call a function call. That's called functional programming or structured programming, procedural programming or structured programming. And then it also has the object-oriented programming feature, so they have a class. Okay, this one we'll talk about it later, but just remember that it is a structured programming, object-oriented programming. It also supports event-driven programming, so you click on a button, you will pop up a window. Okay, those kind of things we call event-driven programming. So in a way, that's actually see this PowerPoint is event-driven because whenever I choose a slice or I click exit, the program will take action only when I click some events, okay, create some event. This kind of program, we call it event-driven. Is that okay? Any questions so far?
No.
No? So that's event-driven program, okay? Okay, so C language is procedural programming, okay? And then C++ Java is object-oriented programming. So this APCSA right now, this OOP already stripped off a lot of material. So in Java 2, we will try to make it more complete in OOP, okay? So we need a Java 2. Okay, anyway, it's event-driven programming. And Android, Google Android still using Java, okay? Android Studio is developed by the Java, okay? So it's the major supporter for Java. But not iPhone, okay? iPhone is different. iPhone use Objective-C. Yeah, it's user suite, it's different. Okay, so you need to know about the different structure of the Java API. Okay, Java API. One more thing, okay, let's go back to here. This one, actually, you have the HTML or Python, okay, so those JavaScript, that's actually called front-end design for website. Back-end, you have SQL, you have database. A main program, another program which is run by Java. So combined together, you actually is backend and front end of a website. Okay, so Java not only used for cell phone, but also very useful in website. Okay. So this kind of API structure, we'll talk about it later. Okay, there are a lot of packages that we will cover. Okay, next one, we are going to talk about interpretation levels. So the lowest level, you only have 1 and 0. high voltage and low voltage. High voltage and low voltage. This is 0 and 1. We call it binary. So can you do this? Can you use the electronic signal so that it has multi-level signal? 3 level? Is that okay? That's okay. But why people don't want to use the 3 level? Because they come with more noise, harder to determine whether it's a 0, 1, or 2. If you only have a binary, it's easier to know it's 0 or 1. So in terms of circuit design, binary is better than ternary. Is that okay? That's why modern computer always use binary numbers. Is that okay so far? Then you use electronic devices to design an inverter. So you have high input, your output will go low. You have low input, your output voltage will go high. This is called an inverter. So 2 inverter, your signal will be, we call it an amplifier. Okay, and you can also design NAND gate, OR gate, or different logic gate based on this kind of, we call it CMOS structure. So you do transistor to build your logics. And then using those logic, you build your number systems. So in chapter 2, we will talk about the binary number system. Okay, anyway, right here, I don't want to go too deep, but we are using the binary system. And then you actually want to use the different logic design to design your CPU, A15, A16, A17, okay? And then M1. So putting more and more core in there, putting more and more transistor in there, putting more functionality in there using 5nm process, building M1 Pro. Okay, now it's M4 already, okay? M1 Max. So the lowest level is machine language. Machine language is always 10100101. It's always binary. It's not known by the computer. Computer only know about binary. Okay. So your hardware and software, you need to put your machine language right here to drive your hardware. And your program is on top of the machine code. And in between, we call it instruction set architecture, ISA. So x86 is one ISA, okay. ARM is one ISA. These are different processor architecture code, okay. So a machine code is like this. You have opcode, operator code, okay, opcode. And then you have mode, register, data, okay. So your different instruction is coded into the machine code like this. They have different definition, okay. Here just to show you the format, okay. And then there's a one-to-one mapping between the machine code to assembly. So assembly say you have this, it may be a opcode of 001111, okay, and register 1 assumes 0001. Register 2 is 0010. Register 3 is 0011. And then this is its machine code. So machine code and the assembly, there's a one-to-one mapping, okay? And then the translation is using the assembler. But we still call the assembly as a low-level language. So we do use an assembler to do simulation assembly. Okay, so we do have the 8086, 80x86 assembly. And then there's an assembler and debugger. And then this one, we call it CPU data path. Okay, anyway, any questions so far? This is actually too much hardware, okay? It's okay. We are going to down soon. So next one, we go to the high level language. So this kind of machine code, actually, we really cannot appreciate because we are human. We don't really read that. So we kind of more familiar with this. This we call it high level language. So you can put this file into memory location 1. Okay. So you actually do 5 times 5 multiply using 1 instruction. And then the result stored in register 1. And then you do register 1 times another number of the 3.1415 and then store in register 3. This is multiply again. So this high-level language may be translated into 2 or 3 different low-level language. Okay, so this is compilation. So that's high-level language to low-level language compilation. So your high-level language need to directly compile to machine code or compile to assembly, and assembly being assembled to machine code. Okay. So that actually is the process of the compilation from high-level language to low-level language to run. Okay. This different level of translations. Any questions so far? Any questions so far?
No.
There are tons of language, so I'm not going to repeat it here. Okay. You just need to study knowing about how many languages there are. These are old already, but these are the very popular languages right now. Okay. In high school, I recommend these different language before you go to college. Okay. Okay, next one, we're going to know more about the project and Java language. Okay, first one is comment. So let's go here. Now let's actually create a new program. This new program, let's call it circle. Okay, again, I am going to actually delete this yellow and white part. We get started from here. Okay, now here we do have this one. Okay, well, I'm going to talk about it later. So now let's actually get started. Right here, let's actually type in public static void main. Okay, string, then right bracket ARGS. Okay, starting from here. So now I want to create a number. So let's call integer. Let's call integer radius. Okay, the radius is 3. Okay, I'm going to calculate the area. So area equal to radius times radius times 3.14159. Okay, and I finish and I do system.out of print line. Okay, right here I can say area. So this one is one string. String is text. Okay. And then you want to print the area as well. So you do plus area. So this plus is connecting your data and the string together to form a new string. So this one is compile and let's run. You'll get an area of this. Any questions so far?
Wait, I have a question. I didn't quite get why you put double in front.
Double say is the data type is double.
Okay.
Later we'll talk about it, okay? But this moment you just think that integer, you need to say the integer. So in chapter 2, we will talk about it. But right here, I just show you a simple program to do it, okay? Okay, anyway, sometimes I don't like integer 3. Let's do this. Let's comment it out. I do double slash. So double slash will comment out the rest of the line. So starting from here to the end of the line is useless. So right here, I need to define the radius. Okay, so I say integer radius equals 4. Compile and run. Okay, so that's a new. So this one become useless. Sometimes not just one line. Actually, the whole thing I don't like it. So I use a slash star slash. Then this whole block is become useless. Now area I don't have definition. So let's actually do double area equals 10. Then it's just 10. So this become useless, this become useless. These are two kinds of the comments. Double slash to comment out the rest of the line. Star slash star star slash. This one is called block comment. Any questions so far?
No.
In Python, this one is sharp, right? In Python, this is quote, 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 and then quote, quote, quote. Okay, it's actually a comment in Python. Okay, there's one more kind of the comments, double star, when there's a slash star star. This one is Java document. Okay, this is Java document. What is a Java document? Let's do this. Let's actually put my name on it. So let's put Eric Chow on it. Okay. And then right here, this one come with a date. So let's do 06/07/2025. So this one become with the author name and version. So here you do see there's a source code, right? Let's pull down to documentation. What happened is that you give you the documentation page for this program. So they will say the version, the author is specified by those Java documentation. Is that okay? Hello, is that okay?
Yeah.
So I
Yeah.
can switch back to source code. Then it becomes this. I can switch back to documentation. Okay, let's actually get out of here. Let's actually don't go there. Let's actually go to chapter 1. So right here, because I use the documentation, there's a directory called doc being created. Now let's go to this doc. So this one actually there's a few HTML code. So in fact, this index file, let's actually open it. Okay, let's open this index file. So using Google Chrome to open it, it is a web page. That documentation page actually is a web page. Okay, if you don't like to use the Google Chrome, let's actually open with Visual Studio Code. You will see it's an HTML program right there. It's okay. So for students that take my APCSP last year, you should be able to read this kind of the HTML. Does that make sense? Belinda, is that okay?
Yeah.
So this documentation page are, so you copy this one to a different website that will work, that still will work, okay? So basically your project can generate the documentation page real quick, okay, real quick. Just switch back to your source code. Then you would get it. So three kind of comment. / to comment on the rest of the line, / star / slash that actually comment on the column line, the whole block. Then / star, this one is the Google Java standard documentation. These three are all different comments, okay? But they have different purpose. Okay? That's Java comments. We are almost done for this chapter, okay? So the Java doc, we talk about what is Java doc, okay? And then you create web page. And then Java doc is defined by this kind of comment, double star comments, okay? And then here are definition of different Java doc comments, okay? This is beyond AP, so we don't go into detail about this comment tag. So AP subset. So when you take the AP exam, they only test you on AP subset, okay? It's very simple. So we will teach beyond AP subset. But if you hear the word AP subset, it just means some small part of the Java being tested in AP, okay? But when we teach, we're to teach everything, okay? We teach everything. Java coding habit. Number one, you want to have the class name to start with the leading capital, okay? Second word also had a capital. Variable, you want to have the lowercase, okay? These are habits. That means that you don't follow it, it's still okay. The main program, you always start with the public static void main, this one, okay? Your program will get started from here when it runs. And sometimes you put your curly brace like this. This is one style. Sometimes you put it like this. You put here and here. I personally prefer this way, okay? Because it saves one line. I personally write this way. You can compare this style and the previous style. Either way is okay, but personally I prefer this style. Okay, any questions so far? There's no right or wrong, okay, in these two styles. It's up to you. But I personally like this way because it's shorter. Okay, here I have more of the convention, okay? So usually your package name is all lowercase. Class name is upper case. Upper case means the leading letters are upper. Okay. Then your variable name, your method name usually are lower case. Lower case means the leading letter is low, but second words the leading letter are uppercase. It's called lower case. So compare this lower case and upper case. Upper case for class name, lower case for method or variable. And if you have a constants, usually it's all uppercase. Okay, it's all uppercase. Okay, so here you have one preferred convention and one not preferred one. Okay. This one on the left, this one not leading letter. This one constant need to be capital. Okay. Okay, we're done with chapter 1. Any questions so far?
No.
No? Nobody has question? Okay, then what you need to do is after class, you actually want to go to the website, work on the quiz, homework, and project, okay? Work on it and submit it. And then when it's due, next week's class time will be due, okay? And then I'm going to actually register your submission record using this file. Okay, I'll put you're missing or you already done or something. Okay. Okay. If no question, then we can be dismissed. And then for those of you still haven't installed the software, you can stay, okay? Otherwise, you can be dismissed. Good night then for students who don't install software. Good night.
Thank you.
Thank you.
Thank you.
Thank you. See you.
Bye-bye.